Hello, in this video we are going to solve again ordinary differential equations, but in this time we are going to use substitution method. This is one of the hardest methods, but if you grab the method and solve more and more questions, you will master it. Let's look at the example. Let's look at the example one. We have something y prime is equal to x squared plus y squared over 2x squared. This is the difference from our previous video because in this video their variables are separable, so we can easily move it the values with x on the next to dx, but values with y to the dy. But this is a little bit different because they are not separable. So what we gonna do? We should write something y prime is a times y over x. So we should write this equation in the form of this. So what we do, we have write y prime is equal to, we divided this x squared to 2x squared plus y squared over 2x squared. So if we simplify it, so the x squared cancel each other, so we have 1 over 2 plus 1 over 2 yx squared. As you can see, we can get this one. So what we write? We write u is equal to y over x. This is our substitution. And y is equal to u times x. We can write v times x, u times x, it doesn't matter what letter you use. So we have y prime here, okay? So we write here, instead of y prime, we take this one. We should find the prime of this. So we have ux prime will equal to, so we have, this is y prime. Instead of this, we write ux prime, and we have 1 over 2 plus 1 over 2, and instead of y over x, we use u. So we have u squared. So let's find the derivative of this u times x. So you know that when we have multiplication, when we find the derivative, we use derivative of first one multiplied by second one plus second derivative of second variable multiplied by first one. So we have u prime times x plus u times x prime is equal to, and also we can say that we have u prime x plus, and x prime is 1, so we have plus u is equal to 1 over 2 plus 1 over 2 u squared. So we can keep it here. So u prime x is equal to 1 over 2 plus 1 over 2 u squared. And we move it here, so we have minus u. And we can do something like this. U prime x is equal to, so from the basic, let's say, factorization, you know that this is equal to 1 over 2 u minus 1 squared, because it will be u squared minus 2u1 and minus 1 squared. So if we open this, we will get this one. So from this, what we can do, this is just now it becomes, the separation of the variables. So we move u minus 1 square under the u prime. So from this, let's write like this, that we will not lose what we have here. So we move this under this one, and we move it x here. So we have 1 over u minus 1 square u prime is equal to 1 over 2. And here we divide it to this one, so we have x is here. So again, we have, instead of this, we write 1 over u minus 1 squared du over dx, and it's equal to 1 over 2x. Again, if you are familiar from my previous video, what we're gonna do, we move dx here, and we keep it here. So we have 1 over u minus 1 squared du is equal to 1 over 2x dx. So we integrate both sides. I forgot to write integration sign here. So what we can write here. So we can use here substitution method, and when we have integral, so we can write u minus 1 is equal to v. So we do this substitution. So we will have here like dv is equal to, and like here du will be dv. So we can write here 1 over v squared is equal to dv. Because like when we find so it will be dv over du, and that will be 1. So we have dv is equal to du. So 1 over v squared is equal to 1 over 2. And integral, again, we have 1 over x dx. So from this, it is v over minus 2. So let's write like this. Let me just write it as a, so it's v to the power of minus 2 is equal to dv is equal to 1 over 2, 1 over x dx. So from this, we will have 1 minus over 1 plus 1, and this is equal to 1 over 2 ln x. And of course, we have here c. And from this, we have minus 1 over v, and is equal to 1 over 2 ln x plus c. And from this, of course, we substitute v with u minus 1. So we will have minus 1, u minus 1. Oops, so why we will lose it. So it is minus 1 over v. So we have this, and it is 1 over 2 ln x plus c. So we are we are getting it somewhere. So what we do here? From this, we just turn everything upside down. So we have u minus 1 get up here. So, and we have, of course, minus, so 2 get up here. And this minus 1, we move it here. So it will minus 2. And we have ln x plus c. And of course, what we get here, u is equal to 1 minus 2 ln x plus c. And as you know that what we have here, we have, instead of u, we can write y over x. So y over x is equal to 1 minus 2 ln x plus c. And if you multiply everything by x, we have y is equal to x minus 2x over ln x plus c. And that's the final answer. This looked like a little bit harder than separation of the variables, but at the end it comes to separation of the variables. So if you haven't watched my separation of the variables video, you should definitely watch it, then come back here to watch this substitution method. Believe me, you will solve every single question in ordinary differential equations. Let's look at another example. Let's look at another example in the separation, not separation of the variables, the substitution method. Let's see 3xy prime is equal to 3y plus y squared over x. And of course, we have some condition here, x cannot 0. Again, we should move it the form like this. As you can see, it's nothing like this. So you can pause the video and try to solve this question by yourself, and then come back here and solve it by yourself. But let's look at this again. So in order to make it this in this form, we divided everything by 3x. So divide everything by 3x. So we will have y prime is equal to 3y over 3x plus y squared over 3x squared. And from this, we have y over x because 2 3's take each other and plus 1 over 3 y squared over x squared. So again, we will have u is equal to y over x or y is equal to ux. Again, we have ux prime is equal to, so instead of this, we write u plus 1 over 3 u squared. So if you, as you already know that how we open this derivative, so it will u prime x plus ux prime is equal to, again, u prime x plus u is equal to u plus 1 over 3 u squared. And you can see it becomes easier. So these two u takes each other. So we have u prime x is equal to 1 over 3 u squared. And from this, we can move this u squared under the u prime. So times 1 over u squared is equal to 1 over 3x. And from this, we have again 1 over u. So from this, we have this du is equal to 1 over 3x dx. To integrate both sides. And from previous example, you know that how we integrate this. So I just pass this part very quickly. So I will have 1 over minus 1 over u is equal to 1 over 3 ln. So this is under the 3, of course, because when we move it here, so it's 3 ln x. It's the similar to the previous one, so I just move it some part very quickly. So u is equal to minus 1 over 3, of course, ln x plus c. So of course here, as you know, what I did here, I just moved everything upside down here. So I just move it here. So we have okay, y over x is equal to minus 1 over 3 ln x plus c. Then somewhere here, mistake, minus x over 3 ln x plus c. It feels like somewhere I did mistake. So we have this 1 over 3, and then we move it here 1 over 3 times 1 over x. So the 3 should be, I think this is the minor mistake, so it's not a very big deal here, but so this 3 should be here on the top of that. So instead of this, we should have here 3. But when we turn it upside down, so we have like when it's upside down, so we have this ln x again here. So it becomes a upside down here. So it will be like this minus 3 and minus 3 ln x plus, first there is my multiplied here x times. And something like this. So we have minor mistake. So it's okay. So let's continue with the third problem. So as you can see, when we solve more and more question, the problem becomes easier and easier. So we have again another dy over dx is equal to y plus x squared. So in this one, we can do easy substitution like this. U is equal to y plus x. So after that, what we can have here, so again, we have dy over dx is equal to, so from this, what we can do here, we just have we integrate derivative, find derivative of both sides. Du over dx is equal to dy over dx plus 1. So du over dx minus 1 is equal to dy over dx. So instead of this dy over dx, we just write du over dx minus 1 is equal to u squared. So du over dx is equal to u squared plus 1. And we solve. So from this, it is just previous separation of the variables. So if you are getting it, why I use separation of the variables first at the beginning to explain you that, because every video in substitution method comes to the separation of the variables at the end. Now let's look at the last example, e to the power of y dy over dx is equal to e to the power of y plus x minus 4. In this, again, we use u is equal to, we use this one as a substitution, e to the power of y plus x minus 4. So we find derivative of both sides, d over dx is equal to e to the power of y. Of course, we need to find the derivative of this, so it's dy over dx and plus 1. So this is just u. So we have again du over dx. So we can just write it as a u plus 1. Because this is u, so this is equal to this one. So we can just write it as a du plus 1 because this is equal to this one. Instead of this, this is equal, like this part is equal to this part. So that's why instead of this, we can just write u and we just write u plus 1. So here we have du over u plus 1 is equal to dx. So we just again write this. It's easier to write. So we have again ln u plus 1 is equal to x plus c. And again ln e to the power of y plus x minus 3 is equal to x plus c. And we have e to the power of y plus x minus 3 is equal to e to the power of x plus c. And like this, e to the power u, e to the power of y plus x minus 3 is e to the power of x times e to the power of c. And e to the power of y is equal to 3 minus x plus e to the power of x times c. And y is equal to ln 3 minus x plus c times e to the power of x. So I just write this, so we get this one. So instead of this, we just use this one and we get the answer. So this is all for the substitution method. If you like this video, and comment it, like it, and share it with your friend, and we will finish the ordinary differential equation with the last video with uniqueness of solution. See you in next videos.